there, algebras, and welcome back to your Chapter 13 Lesson 4 notes. Day 2 of them, of course, so just a whole bunch more examples, and here we go. All right, so we want to generate the next 3 terms given a recursive sequence and define it as arithmetic or geometric. Great. Let's take a peek here. I have f of 0 starting with 2, and now I need to find the next 3 terms, and my sequence is defined by taking the next term, so the previous term, and adding 10. So if I start with f of 0 being 2, f of 1, my next term, would be 2 plus 10, or 12. That would mean f of 2 takes my previous term plus 10, getting me 22. F of 3 would give me 22 plus 10, or 32. There's my next 3 terms. And this, of course, is arithmetic in nature because I've been adding 10 each step along the way. What's going on in B over here? So I start with f of 2 equals 10. And to find each subsequent term, I'm going to take 10, and it looks like I'm going to be multiplying it by 2. So f of 2 equals 10. I was trying to get into it before I started with my first given term of f of 2 equals 10. Now I can say the third term, f of 3, is -2 times 10, or -20. I can say f of 4 is -2 times -20, which bounces me back to the positive for 40. And f of 5 is -2 times 40, which bounces me back to the -80. So there's my 3 terms, which of course are geometric in nature because I'm multiplying by -2. Okay, so my change is based on, am I adding to each term? Am I multiplying in each term? If it's just that simple of just adding or subtracting, or just multiplying or dividing, then I can divide it into arithmetic or geometric. If I mix that, I can't just define it as one or the other. So that would be like in exercise 2, where my sequence is defined recursively, starting out as f of 1 equals 4. And then each subsequent term is multiplied by 2 and subtract 5. So we want to get to f of 3. So if f of 1 equals 4, then to find f of 2, I take 2 times my previous term of 4, and I subtract 5. 2 times 4 is 8. 8 minus 5 is 3. Sorry, I was trying to write 8, even though I needed to subtract 5 from it. Now to find my third term, I take my previous term, so 2 times my previous term of 3, and I subtract 5. So 2 times 3 is 6. 6 minus 5 is 1. And that was what I was supposed to find, was f of 3. There you go. So that I can't define as explicitly arithmetic or geometric. That was a combo of multiplying and subtracting. So I had both going on. All right, let's do one more together and then have you try one. How about I'll have you try B and I'll do C. Let's do it that way. So I'm given f of 2 equals 64. So that's where I want to start. And then each subsequent term, we take half and add 4. So f of 2 equals 64. So f of 3. I take half of the previous term and add 4. So 64 divided by 2, 32. 32 plus 4 is 36. Sweet. Now, f of 4 equals 1/2 of 36 plus 4. Half of 36 is 18. 18 plus 4 is 22. So this one is going to start us taking half of 22 and then adding 4. Half of 22 is 11. 11 plus 4 is 15. And yes, that's where we stop. But if I were to go to f of 6, would I continue to get an integer answer? No, because I'd have to now take half of 15, which is not an integer, and then add my 4. So this is where I was asked to go to, but if I had to keep going, I might not continue with an integer. So you do want to watch for that, and perhaps watch for that on B. Maybe you're going to find that in a sec. All right, give it a go. Pause it right here. Try B yourself. Let's see how we do. All right, so I faked you out. Still had an integer answer. Any issues there? Well, you'll have to email me or actually talk to me in person if you have any issues there, huh? Exercise 3, last ones we're doing together, and then we'll get going on the practice day 2, so the homework that goes with this. Let's see. So we have some different n numbers that we're starting with and then continuing from there. So how about I get you started and you get me to 10? Let's do it that way. So let's see. A to the subscript n, where the previous term plus n is how we want to go. Let's start with a to the subscript of 1, and we need to get to a to the subscript of 4 over on this side. So let's see. A subscript 1 is 1. Now what we're doing for a subscript 2 is we're taking the previous value and adding our subscript to it. We get 3. So let's take the previous value, 3, and add the subscript 3. Take the previous value, 6, and add the subscript 4. We get a to the subscript 4 is equal to 10, which is where we wanted to get to. Now, you keep going to get to the subscript of 10. Go right ahead, pause it right here. You keep going on this. Keep going with this. You got this. Pause it here and try it yourself. And as far as this goes, that is really not that bad, right? Did you get a to the subscript 10 equals 55? Just keep showing your work. Show each step. Plug in each previous value. And you can do this. But if you need some help looking at it, please let me know. Make sure you're doing the practice because it does have the former Regents questions in it where we've seen these recursive sequences being asked about. You'll see that they're extremely similar to what we've been talking about. That's what we want to get ready for. Algebras. This has been Chapter 13, Lesson 4, yet again. Good luck on your practice, and I will see you soon. Bye, guys.